Hi, welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at AQA Mathematics Statistics SS1A May 2016 examination question number 3. Let's read the question together. A cafe serves 4 types of bread roll and each roll contains one of 4 fillings. 4 types of bread rolls: soft white, crusty white, soft brown, crusty brown. 4 types of fillings: ham, chicken, egg, cheese. And there are 400 customers. In total, 400 customers are shown in the table. Part A, there are 4 parts in part A, and there's a part B in this question, and which carries 7 marks. Part A, part B carries 5 marks. Let's see what are the questions. Part A, a customer is selected at random from these 400 customers. Calculate the probability that this customer chose a crusty white roll. Crusty white roll. This crusty white roll is in this row. Out of 400 customers, there are 110 customers who chose crusty white roll. Therefore, the probability of crusty white roll is equal to, out of 400, 110 are choosing crusty white roll. Using the calculator, you can find it is 2.275. That's the probability for the part 1A, part 1 of the question. Part 2, a soft white roll with ham filling. Calculate the probability that this customer choose a soft white roll with ham filling. So again we go to the table, soft white roll in this row basically, but we need to find out ham filling. So ham filling is in this column. So basically there are 56 people who chose a soft white roll with ham filling. That means probability of choosing a soft white roll with ham filling is equal to, out of 400 people, 56 people have chosen this option. That means it is equal to 0.14. Using your calculator, you can calculate that one. Okay, so those are the 2 parts in part A. Let's go to part 3 of part A. A customer is selected at random from these 400 customers. Calculate the probability that this customer chose a brown roll with either ham or chicken filling. So when you get a either, so basically you need to add 2 probabilities. That means probability of choosing a brown roll with ham filling, either ham filling or brown roll with chicken filling. So what are the 2 probabilities that you have to add now? So there are 400 customers, and there are, so if you look at the first statement, brown roll, it should be brown roll. So there are 2 rows which include brown roll, softy brown and crusty brown. And then there are 2 columns, one for ham, one for chicken, ham and chicken. So ham and chicken. So those who chose soft brown have chosen 30, number of them chosen ham, 24 number of them chosen chicken. Crusty brown, 24 ham, 26 chicken. So therefore your answer to this question, which is equal to, out of 400 customers, ham filling 30 plus 24 or plus brown rolls with chicken filling 24 plus 26. So you need to add all these numbers, then you get the number 804 divided by 400, which is equal to 0.26. There is a probability for this part of the question. Okay, let's go to the fourth part. Again, either egg or cheese filling, given that there is another condition, given that the customer chose a white roll. In this particular case, we have to assume that a certain limited number of people, not all 400. Given that, that means we know we are going to consider only the customers who chose a white roll. That means these two columns. That means 150 plus 110. That means 260 have chosen white roll. So it is the given that condition. That means probability of choosing either egg filling or cheese filling, egg filling or cheese filling, given that is a white roll. This is the condition. So what we now look at is that, so either chicken filling or egg filling, either cheese filling. There are 17 plus 14 who chose white roll with cheese filling, and 32 plus 21 chose white roll with egg filling. So this egg filling, out of 260 customers, egg filling 32 plus 21, that is soft white and crusty white with egg filling, and soft white and crusty white with cheese filling, plus 17. This is the O condition. 17 plus 14. You could have written two different probabilities and add them, or you can just add at a stretch, and you get 84 over 216. Please note that this is 216 because 60, because it is a given that given the white roll condition. This means we are only considering the white people who chose a white roll, not 400. So once you simplify this one, we get the answer 0.323. Okay, let's go to the last part of the question, part B. You may assume that the 400 customers present a random sample of all customers purchasing rolls at this cafe. 4 customers not included in the above 400 customers were selected at random from those customers purchasing rolls at the cafe. To 5 decimal places, estimate to 5 decimal places the probability that 2 of them chose white rolls with chicken filling and 2 of them chose brown rolls with ham filling. Interesting. Let's see what are they going to ask here. Basically, what they're asking in this case, there are 2 probabilities. Let's simplify it first. Let's try to find out what is the probability of choosing a white roll with chicken filling. So white roll, again we have 2 rows and then chicken filling, 2 numbers here, 45. This is the chicken filling column. So that means if I write the probability of choosing a white roll with chicken filling is equal to, out of 400 customers, you take 45 plus 25 chose chicken filling with white for the white roll. That means 70 over 400. So if you calculate the probability, it is equal to 0.175. Let's assume this equal to P1. And the second probability is that 2 of them chose brown rolls with ham filling. So probability of brown rolls with hem filling is equal to, so go to the brown row, two rows, and hem filling, so brown row with hem filling, so 30 plus 24, out of 400 customers, 30 plus 24 go for brown rolls with hem filling. So that means 54 over 400 brown rolls with hem filling. So this will be equal to 0.135. So let's assume this is probability P2. And let's actually see what is the next part. So let's go to the next page. Let's try to remember this one. P1 is 0.175, P2 is equal to point. So we'll take this one to the next page. That means we have already seen that P1 equal to 0.175, P2 is equal to 0.135. So the question is that two of them chose white rolls with chicken filling and two of them chose brown rolls with ham filling. So let's see why. What is the actual probability that they want to find? So first we'll see that the four customers are lining in a line, and then what is the probability of the first customer choose a white roll with chicken filling? So this is P1. So first customer has chosen a white roll with chicken filling, and again let's assume the second one also chose a white roll with chicken filling, and then two of them already chosen white roll and with chicken filling, and there is a n condition. This is an n condition, therefore this is the multiplication probability, and again and. So because two, this is n condition, two of them P1 P1 and the n condition, we have a multiplication here for the second two. So third person may be taking P2 and P2. That means he may be choosing a brown roll with ham filling, and the fourth one also brown roll with ham filling. So what we get is P1 squared times P2 squared. So interestingly, there are four places, and we need to have two probabilities. So this is a NCR problem. That means it is like we have four places with C and R is equal to 2. So we have four places to fill with two different probabilities, NC 4CR. That means there are 6 different combinations if you calculate this one. That means if you write different combinations, it means you can have P1 times P2 times P1 times P2. So always there can be only two P1s and two P2s. So like that, if you write, there are 6 different combinations, each of them equal to the same probability, P1 squared, P2 squared. So therefore the total probability for this question is equal to 6 times P1 squared times P2 squared. 6 is NC. There are 6 different combinations. You have to add all these probabilities to get the final total probability. So if you calculate, P1 squared is equal to 0.031. We know P1, so square it and put it here, and P2 squared is equal to 0.018. So when you multiply all of these, you can get the final probability 0.00334 to 5 decimal places as requested here. So it worth about 7 marks for this particular question. So this bit confusing question, but if you read carefully, it is quite straightforward. Basically, we need to find out two probabilities and then multiply them and then find the number of combinations that we found it to be equal to 6. Okay, thank you.